Well, hello and welcome to the Toptal Academy React.js Lecture 5. My name is Verde and you already know me by this time, so let's crack on it. Okay, so today what we are going to see is we are going to review that we were using React Redux in order to maintain the local state of our application. So right now our architecture looks something like this. We have our React application wrapper and all the components or the modules of our application are being loaded through the React router as childs inside of our application wrapper. Now with Redux, we are maintaining our state inside of Redux, and Redux is iterating the models through these wrappers. I'm trying to signalize that with this green wrapper outside of the component, which is in charge of receiving the state as props from Redux and feeding that into our components. So that's how we are handling right now our local state. But what about contacting the server? So now if we have to contact a server, Redux will be in charge of maintaining the keep the local state in sync with the state on the server. So basically what we're going to do is we're going to go and fetch the data from the server inside of Redux, and then whenever we have any mutation on our state, we are going to feed that into our applications. But the connection between the server and Redux, it's going to be asynchronous, of course, because they are just network requests, so we are going to have some asynchronicity there going on. And how we're going to solve that if our action creators in Redux are synchronous? Well, this is where we start to learn about Redux middlewares. And this is an important part because what middlewares means. Middlewares are the ability to inject code between the framework receiving and request. So we're going to be able to hook to a specific part of our framework, in this case Redux, and put some code there in between. For those who are familiar, it works pretty similar on how middlewares work for Express, which is common used framework for the server side, or Koa, which is the new version with ECMAScript 6. But it works a little bit different because, as well as on Express and Koa, it provides third-party extension points. So we are going to be able to inject functionality into Redux that Redux doesn't provide out of the box. And where we are going to inject this functionality between dispatching an action and contacting the reducer. So mainly there's where our middleware is going to interact. So let's look at an example. First, the most common example for middlewares is just logging. Let's say that we want to log in what's happening with our actions before we dispatch an action and after we dispatch an action. In this case, I don't have access to the state, but it would be, of course, interesting to show the state before and after a mutation or an action. So let's take a look at that in code. We're going to see, let's close this, and we're going to see here, it takes, for example, the container add. Let's say that we want to know what's happening before we add a new person to our list and after we add a new person to our list. So let's see. Now we'll go to add. We add some things, some strings here. We'll click add. Now we are logging that our action were triggered, and we can see the actual content, the payload. Increase the font here a bit. We can see the payload of our actions. Let's put it like this. So so it's more clear. And well, in this case, I'm just logging the payload again. So that's the functionality that we're trying to achieve. And we can do this in several ways. We can just create a function to wrap our dispatch, because if you take a look at what we are doing here, we're just adding functionality before and after calling dispatch. So of course, in a functional language as JavaScript, we can just create a wrapper function and add the functionality before, and then execute the function that we're calling, and then add some functionality after. If we take this to another level, we can say, okay, if we have the dispatch method inside the store object, why not to create a function, in this case patch store, to add login that receives the store, and it saves references to the old dispatch function in the next variable, and then we change the dispatch function to be a new function, which is in this case the one that is going to dispatch and log. And then now we have access to the get state because we have visibility to the store through closures there. So we can receive an action in the dispatch, in the new dispatch function, and log the action, and then execute the action with the old dispatch, which in this case is going to be next, save the result, and then log the state after the action was executed, and then return the result that we are saving for the dispatch execution. So let's take a look at how that would look. In this case, I'm going to modify my store definition here. So what I'm going to do is just create, I have this patch store to add login function here. It's the same one that we just saw. So what I'm going to do is just call this function after we created the store. We created the store by combining the reducers, and then here I'm going to patch to add the login. And let's take a look at how it looks. There we go. So now I'm going to add again something, and there it is, marvelous. So in this case, now I am first logging the action that I'm about to execute with the action type and the payload, and there, after the action was executed, I can log the state of my application. In this case, it's going to be the list with the new person added. If we go to the list, we can see it there as well. Perfect. So with this pattern, this allows us to create several functions that are wrapping our store dispatch. So we can, for example, create here, this is another sample middleware, which in this case is just testing if we are throwing an exception, and then we can catch that, we can console that, the error to the console. We can log the error to the console, or we can save it to our server, or we can do whatever we want to. It's middleware, so it allows us to execute any code that we want in between dispatching an action and leaving that to reach the reducer. This is only to show that with this pattern we can concatenate middlewares by just calling these functions again and again and again, and then those functions will be patching the store dispatch method and adding their own functionality, wrapping the original function. So of course, in the first call we are going to patch the original dispatch function from the store, and on the second call we're going to be wrapping the already wrapped dispatch function. So it's going to work anyway. We are not going to throw an exception, or we can actually, just to show you. Let me go to, let me add an exception here. So yeah, gonna go into the action, add, and we are going to throw an exception. Yeah, perfect. Perfect. So let's see what's happened. Under this, we are just catching our exception and reporting that to the console as an card exception. So we're going to remove this, and that's it. Basically, the idea of the middlewares is that you can wrap all the functionality between several amount of middlewares. And that will allow you to not depend on what a previous middleware or the next middleware is doing. So, okay, that's a middleware, fine, but what about the asynchronous way of contacting the server? Well, for this, there is a special middleware called Thunk, which is this one-liner middleware. If you take a look at this, let me first explain you how we get into that one-liner code. If we take the idea that we have here of creating a function that receives the store and then saves the reference of the dispatch function in the next and then override the dispatch, well, we can take that a bit further and say, let's create a function that it's called logger that receives the store and returns another function that will receive the next instead of reading directly from the dispatch, directly from the store. And then that function is going to return another function, which is going to be the actual middleware. That is going to receive the action, and it's going to have a reference to the next middleware through closures here, and it's going to have a reference to the store through closures here. So this is doing basically the same functionality, but is allowing the framework in this case to provide us with the next middleware. So we can take this even a bit further and just create a logger function using the notations from the syntax from ECMAScript 6, which is going to be arrow functions. Is just a function that receives a store argument and returns a function which receives a next argument, which returns a function that receives an action argument, which is the actual middleware. But the notation makes things a bit more simple. And then this kind of middlewares is exactly the kind of middlewares that Redux is expecting from us. So what we can do here is when we're creating the store, we can say, okay, create this store with this combined reducer as we saw on the last lecture, and then we can use the apply middleware function, which is going to modify the create store function to create a store with this middlewares on the dispatch function. So we're going to say apply middleware, and in this case we are only going to send the logger there as a reference there, not as an execution. So let's give it a try. Oh yeah, missing one parenthesis. Perfect. Okay, so let's give it a try now. There it is. It's still logging. As you can see, I just commented the lines before, so now the login is coming from the applied middleware. So now this is a valid middleware for Redux. So you can take this function signature and add your own functionality to Redux. Okay. So going back, how we're going to solve the asynchronous part of the server. Well, there is a special middleware that we call Thunk, which is just one line, as I was showing, In this ECMAScript 6 notation, it has the signature. There is a function that receives the store, which returns a function that receives next, which returns a function that receives the action, which is the actual middleware. And then it's just going to check if the action type is function. Remember that the action creators were always returning plain old JavaScript objects. So if it's not returning an object, but it's returning a function, then it's going to get into this thunk. And what this is going to do is, instead of sending the action, the function action, to the next middleware, it's going to execute the action, but it's going to send a reference to the dispatch and to the get state. So in this case, our asynchronous action creators are going to be coupled with this thunk middleware. So we cannot have asynchronous actions if we don't have the thunk middleware there. And what the thunk middleware does actually is just sending the reference of the dispatch and the get state functions to the function action, to the asynchronous action creator in this case. And if it's not returning a function, then it's just a plain old JavaScript object, and it just sends it to the next middleware. So that's the action creators. So how we're going to use them? Let me switch to the other example here. Stop this. Here for the server. Okay, now that we have asynchronous action creators, we're going to have to change our application a little bit. The main thing that we're going to do is we're going to change the shape of our state. Right now we only had an array of the persons, which is fine for local state, but as we are now going to try to keep our state in sync with our server, we're going to need a couple of extra variables there. For example, to know if we are fetching data or if we already finished a request, failing or receiving the data. If we are failing a request, we need to send an error string to have there to know if something failed. And finally, we can have our list of data if everything went okay. So our initial state is going to have its fetching in false because we are in node initially fetching. An error string set to an empty string, and list in this case is going to initialize with an empty array. So our list of our persons is going to be empty by default because we're going to retrieve the first list of persons from the server. So let's take a look at that, what we did on our reducer. Here we have our initial state there. And another thing that we have to do is we are going to change our actions. And this is an important part because on our previous example, the actions were all about mutating the state. But in this case, we are not going to mutate the state unless the server is approving our mutations. So mainly the server is going to be in charge of mutating our state. So our actions are going to be all about contacting the server. So we're going to have a request action, a receive action if everything went okay, and a fail action if something went wrong there. So let's take a look at that in the code. And right now our actions are going to be request, receive, and fail. As you can see, we still have our synchronous action creators for request, receive, and fail. Now I'm not exporting them because I'm not going to use none of these three action creators from the containers. I'm going to use another one, which is actually our asynchronous action creator, which is going to be called fetch. This is to make it similar to our previous example, contacting the server. but we can go much deeper and create different kind of patterns here. But for now, let's stick to the fetch. We're going to receive the name of the action or the endpoint that we want to contact, and the data that we want to send. Now, our action creator is going to return a function. So if returns a function, it's going to be catched by the thunk middleware. And the thunk middleware is going to call our function sending the dispatch reference, which is all what we want in this case. And we're going to dispatch a request action to signalize the state that we are starting a request to the server. So after that, we are going to just return promise here from Axios. Remember Axios that we used on the lecture 3? Well, we're using the same. We're going to post, we're going to use the same pattern. We have the URLs coded on an object, and then depending on the name is the URL that we're going to contact, and then send the data. And we're going to check if the result from Axios was correct. We're going to dispatch a receive action with the same name, and we're going to just send the data received by Axios. So let's take a look at how that looks. It is a bit more complete here because I'm also catching the errors with this is coming from the specification of Axios, so you can take a look at the documentation there. But mainly what I'm doing here is just returning the function that received dispatch as a parameter there, and then dispatching the request action, which is going to have this format here. And then I'm going to check if everything went okay. The receive action is dispatched, and if some error comes, I'm dispatching the fail actions here. So how that will look on our reducer as well. Our reducer changed dramatically because our actions changed. So now we have to check which kind of action we are expecting. In this case, for starting a request, we are going to signalize that we are fetching, we are resetting the error to an empty string because maybe we had some failure before, so we have to reset that. And then we are going to check if we are receiving data from the server. Then we stop the fetching, we signalize that we didn't receive any error. We get the data that we received from the server, and we put it into the list. Remember that this is working like this because of the way that our server is returning always the list of the persons. So as we are performing any mutation, if we are adding, deleting, or editing, we are always returning the array of person as the result set. So if the addition fail, we are returning the entire array of persons without any change. So specifically, our API was designed to be simple to contact through Redux, but we're going to see on further lectures more complicated cases for APIs. Finally, if we're failing, we are going to set the fetching to false, and we're going just to show the error string. In this case, we are not resetting the list because maybe we had some correct data from a request before, and everything is okay, so it's not going to perform any problem. Now, other thing that also changed for this is our containers. Before, our containers were just dispatching the actions to perform the modifications. So right now, instead of dispatching the specific actions, all are just dispatching the fetch action, and we are changing the name of the endpoint that we want to contact. Remember that the name was just to refer the URL that we want to use for list, for add, for del, and for edit in the actions file. So come back to the containers. We are just fetching, in this case, from the add action, and we are sending the person that we're trying to add. When the request is received, when some data is received from the add action, when some data is received, then the reducer is going to catch that into the person received case, and then it's going to load the new data into the list, which is going to feed through the list container, sorry, here, in the map state to props. I changed it also, now all the containers must to map the state to the props using the list property of the person's object, because right now persons stopped being an array and now it's an object, and the array is inside of the list property. I can also say it here, for example, send the error string, and then if I receive in my list component, I could have the error prop types dot string is required, and well, I should be sending here. I'm going to do it like this, div props that error, and then if I'm receiving an error, then it's going to be shown on the bottom part. I'm going to try to test this. Okay. I also changed our list screen component, because right now our reducer has an initial state with an empty list. So the first thing that I have to do is load the initial data from the server. So when component did mount, I'm going to receive a special function called onInit, or it could be load or everything, but in this case I just set it to onInit. And then on my container for the list, in the onInit dispatch to props, I'm just dispatching the fetch action creator with the list action name. So let's take a look at that, how it works. And we're going to have to take a look at, well, here to the network tab on the inspector. So every time I reload my application, I'm going to see that there is a request to the API there for the data initialization. So now I have this coming from directly from the server. So I can just say, let's add. When I click add, we're going to see that it's adding to the server. It's sending with the headers, it's sending the object there, and then the response is with my new person added as well. So if I go to the list, in this case I'm just doing another request, because remember that every time our list screen is being loaded on component did mount, it will call the onInit, so it's going to retrieve a new version of the list. This is best to keep the data fresh, but if you don't want to be hitting your server again and again and again, you can make some optimizations by just on the actions saving the current date for each response from your server. So you can add, for example, received at, and then mark the data as it was just received, something like in the action. You can just say, let's see here in the receive this, see at, and you can say here new date, right? Remember that you cannot do this on the reducer, because the reducer must be a pure function, so it doesn't, it couldn't have any functionality outside of the function itself. It cannot mutate anything outside of the function. So calling the date, it's not allowed inside of reducer, but it is allowed inside an action, so you can do it in the action. So basically that's the way to contact our server. So we're going to lock the server and go to list again to see. Okay, let's go to add, and I'll go back to list. And here I have my network error present, as you can see there. If we load the server again, see there it's the network error. If we load again, and we are going to see, of course, we are not persisting the server data into any database, so it's going to reload without the added person there. So that's mainly how to connect an application with a server using Redux and using async action creators. We had to learn middlewares in order to create that, and we had to learn how to use the Thunk middleware. Okay, that's it for today. It was, I think it's the shortest lecture, but if you have any doubt, please contact me on the Slack channel. Thank you very much.